This is example 10.5 from Discovering Design with Chemistry. A chemist is converting iron 3 oxide to iron via the following reaction, and then it has a chemical equation. If the reaction consumes 8,615 milliliters of carbon monoxide, what volume of carbon dioxide is produced at the same temperature and pressure? Now, this might sound a little bit tricky, but if you are doing this right after reading the section of the book that it's in, we just learned that when all the substances of interest are gases, as long as the pressure and temperature remain the same, the chemical equation gives you the relationship between the volumes of those gases. So if we have 1 mole of iron oxide and 1 mole of 3 moles of carbon monoxide, that will yield 2 moles of iron and 3 moles of carbon dioxide. The ones that are gases, not all of them, but the ones that are gases, which would be the carbon monoxide and the carbon dioxide, because they're both gases, those numbers in front, the three, those mean that that is the same ratio and the relationship between the volume units as well as the relationship between the number of moles those things have. Now, it only works for the gases that we are interested in. The solid ones, if it were one of those, we would have to do a lot more work to get that. So we learned that we have 8,615 milliliters of carbon monoxide, which is this one. So we can just point straight to that number. And they want to know the volume of carbon dioxide, which is this one. You can probably tell, since they both have 3's in front, that they have the same, we would call it a coefficient in like an algebra equation, but because they both are 3 of this and 3 of that, it's going to be the same volume in amount too, but they won't always have the same matching number, and sometimes you'll have to multiply or divide. So we're going to work through that anyway. So we have 3 milliliters, or whatever unit you want, of carbon monoxide is going to be the same as 3 milliliters of carbon dioxide for this particular chemical equation. And because we have 8,615 milliliters of carbon monoxide, we can take this relationship that we just wrote down that's based on these numbers right here, and we can multiply this by a conversion factor. So we want to get rid of milliliters of carbon monoxide, and we want to figure out milliliters of carbon dioxide. This one has a 3, so we put a 3 on the bottom. This one also has a 3, so we put a 3 on the top. Our units will cancel, leaving us with the units that we want. And you can see that when we do the relationship, because we have a 3 over a 3, that actually simplifies to 1. In other words, we're not changing the number, which is why you really didn't need to do this complicated, not complicated, but you didn't have to do this extra step of using a conversion factor. You could just look and say, hey, they both have a 3 in front. That means they're both gases, and so they have the same volume because they both have the same number in front. If one of them had a 3 and one had a 2, using this conversion relationship would have helped to make that a lot easier, so we kept our numbers in order. Or if they weren't both gases, we couldn't have used this idea at all. Anyways, 8,615 milliliters of carbon dioxide are produced, and so that's our answer.